Right. Oh, actually, sorry. I need to get my microphone. Just a moment. Brought both just in case. So let's see if. Testing, testing. Hope that works. Let's clip it on somewhere. Sorry, I hope that wasn't too loud. Something like that. Hope that stays on. Maybe I should put it. So this is the clipping on the microphone string. Exciting. So yeah, hi, welcome to the. Oh, it's still using webcam mic. Yeah, maybe that's it. It wasn't loud because it's not on. Mic auxiliary, Logitech webcam. Active sources only. So all of these are active. The webcam is yeah. Well, if you can hear me, I guess it's all right, regardless whether it comes through this microphone. The original reason I got the microphones was that the moment I turn on the fume extractor, my voice wasn't really audible. So I'm not gonna use the fume extractor today, probably, spoiler. So I think it should be all right either way. So yeah, anyways, welcome to another episode of the New Old Computer Show. Oh yeah, when the extractor. Yeah, I'm not gonna turn on the extractor. And yeah, hope that will be all right. I'm just gonna do a quick test of this. I'm gonna share my computer monitor, I think, for a couple of steps today. So this is the eternally. Let's close these out. So I just wanted to check: are you able to see this screen? For instance, can you see the XG Pro programmer window that shows up all right? So let me know if you saw that. So yeah. Anyways, so this might be the last part. Hopefully, I'll knock on wood. We'll see. But it may be the last time we tinker with this Mac SE30 because yeah, thanks Brendan. Funny story. This computer was actually fully functioning. Essentially, like there was no fault, so to speak, with this computer when we left off. In the last episode, I had changed out the ROM SIM slot, and we were still running into macOS hanging when it was booting. Now, this is sort of kind of a noob warning amateur hour kind of situation where there was a very good explanation for that, which is that was me running a custom ROM. So this is a ROM sim with basically a hacked Mac 2SI ROM on it. A 2SI ROM that removes the memory tests in the beginning, so that it doesn't take 5 minutes for a vintage Mac with a more than 32 megs of RAM installed to boot. I may not have been explicit enough about that during the stream, so I know folks who are actually knowledgeable about this could have pointed this out to me. But if you, by the way, okay, so recap for folks who may not be fully on top of this. The original Mac SE30 ROM is a 256K ROM, I believe. Yeah, let me see. I'm pretty sure it's a 256K ROM that has 24-bit memory addressing. And I'm not the best person to explain this, but the upper 8 bits of the memory space was memory addressing was used for ROM calls, I believe, like system calls. Early on in the addresses were used early on in the very first version of Mac OS. You know, in the Mac 120K, 512K plus, etc. You know, memory was at a premium, so a big chunk of the OS itself was resided in ROM, and the software was making calls to addresses for methods in that ROM, and that address space was was then for backwards compatibility reasons occupied or used by software in that manner. And that meant that when memory became fairly cheap and abundant, you run into problem with addressing, because but basically the early 68 or 20 or 30 Macs were limited at 8 megs of addressable RAM out of the factory, out of the box. And there were software there's I think there's a control panel to or extension to bypass that and to add more memory addressing to early Macs, but there was still a little bit of a, you know, software hacks and things going on. So it wasn't until the sometime in the very early 90s, Apple came out with a so-called 32-bit clean ROM that enabled up to 128 megs out of the box. You know, you can install big sims and get lots of memory. And so basically what you know, the early modders did, I think people started figuring this out in the late 90s, was if you dropped in a Mac 2SI ROM sim, the early revision Mac 2SIs. Actually, this is an example of a Mac 2SI ROM sim. Fortunately, this one is defective. If you drop that into a Mac SE30, you will get 32-bit memory addressing. Now, of course, Mac OS does a bunch of checks for this. It does, of course, ROM checksum. Checks are going on various points in places in the code, and 32-bit addressing checks. So if you try to boot Mac OS 7.5 on a Mac SE30 that has a 32-bit clean ROM, it's gonna hang. You know, that's what we saw last time. That's why it was hanging. And I had read about this. I knew about this, you know, from years back, but I just didn't put one and one together. The other problem, so then I was kind of thinking about, well, maybe there's something with the ROM, right? So I popped in the original. Actually, it's sitting in this machine here. Let me just pop it down here. So I put the stock ROM back in here. And if you remember from the last stream, we got sad Mac chimes. Well, again, noob warning. That's what happens when you have very large capacity sims installed in a Mac SE30 with the stock ROM. So I had 16x4 ROM sims. Maybe it works if you have all 8. I don't know. Somebody mentioned that if you populate all 8, you may have better luck. But basically, so what we have right now here is the stock ROM with 8 1 meg sim modules. And now this computer works perfectly fine. So let's just have a quick look at that, just to show that it's working. And I'm gonna tilt it up again to demonstrate. So nothing's touchy. There you go. So that's a happy Mac chime. You're gonna see the gray screen there in a moment. We're gonna get the flashing floppy disk in a moment as well. So oh yeah, of course I should demonstrate that System 7.5 boots as well. But before I go into that, I want to do another couple of things. So and I'm gonna show the diagnostics in a moment as well, just to show that everything is checks out fine now. Of course, we still want more memory, right? I have 64 megs of RAM. I actually ordered another 64 so I can max this computer out later on. So we definitely want to go in and do the hacks that you need to do on the Mac OS system files in order to bypass the 32-bit addressing and ROM checksum stuff. So we can do that later, maybe. And also, fun thing, we do have since we have this Maxim SIM PCB with 4 nice little PLCC sockets, we can actually program our own ROM. We can put whatever we want. And I was playing around with that earlier, and I was able to, or basically, I failed to get a bootable ROM disk. So I did find a 2 meg ROM image. I split it up into 4, put it on these chips. Doesn't work. I may have to do some bit swapping to make that work. I don't know. I'm not even sure what capacity these. I think this is flash memory. So we can at least go and restore this ROM sim back to functioning state in a moment. So yeah, I have a programmer sitting over here. This is what's it called? Xgeku. I don't know what's the right pronunciation is. It has a PLCC32 pin adapter right now, so I can program whatever I want. And one thing we can try also, we can pull these chips off. We can do some hot air rework and read these in the programmer and see what we get. I know, because this doesn't work in a 2SI, it doesn't work in an SE30, so I'm pretty sure that there's something wrong with this. The SIM, probably one of the chips have gone bad. So let's turn this off for a moment. So the other thing that happened since last stream was after I wanted to do some more troubleshooting, so I wanted to put this computer back together, slid in the logic board again, put the case back on, and for very bizarre reasons, the screen started collapsing. The video signal gets this. Well, we can see if it happens again. But basically, to make a long story short, this computer right now has a different analog board and a different neck board installed than what it came with originally. So they are from a different SE30. And I want to try and restore the original. So the couple of things. So when you see the screen collapsing, and also there were the system reset a couple of times as well. Sorry, silence my phone. You want to think that a cause could be something shorting out, right? That could be one thing. So I was thinking, well, is something shorting out from the logic board to the chassis that shouldn't be? And I couldn't immediately figure out if that was happening. There's nothing obviously touching, or there's nothing obviously exposed on the logic board. And the second part of course, these analog boards run pretty hot, so the headers and the interconnection cable headers, as well as the solder joints may go bad, and also components may go bad on these. And now this SE30 didn't seem to be very heavily used. It was almost pristine in the analog board, etc. It was in very good shape. So I did go over the back of the analog board. I looked for cracks in the solder joint, the microscopic cracks. Couldn't see any that were obviously bad. I did try out mix and match different components, and the current theory is that there is poor connection in the neck board. So probably in the connection of the neck board itself, perhaps the pins on the neck board on the CRT there, are oxidized. And yeah, so this neck board is different. This is also a different neck board than it came with. So I'm gonna try that. I'm gonna try and put the original analog board and neck board back on. I'm gonna put it back together. We're gonna start using it a little bit, and then we'll see if the screen collapsing fun stuff starts happening again. So yeah, let's do that. This is maybe it's a little bit of a tutorial for how to swap out analog boards in Compact Macs. Just gonna put the logic board away for a bit, maybe over here. So this computer was on a moment ago, so good practice to discharge the CRT. I think the bleeder resistor is pretty good on this one, so I have never seen any spark come out of this, but it's, you know, better safe than sorry. So this is good practice if you want to work in CRT systems, monitors. So that Apple's maintenance manual suggests that you should always attach the other end of the discharging tool to the other end of the what's it called, ground lead that goes from the neck board, because that will allow the high voltage to dissipate safely through the chassis. I've heard, you know, I heard from people who've made this mistake, but if you clip it onto the side of the chassis here, and you have the logic board installed, the high voltage may take a shortcut through components on your logic board instead. And I saw somebody mention that they fried a couple of ICs on their Mac 128K by doing that. And yeah, the Mac 128K, 512K, and I think early pluses don't have bleeder resistor, so they're gonna have sparks going on. There's gonna be a couple of thousand volts in those things. But anyways, so you wanna. This is not the best tool ever. So you wanna lift it up a little bit, put the screwdriver inside. No spark, so we can safely detach the anode cap. It's a little bit awkward angle, but you wanna push on one of the clips inside. It comes out. There we go. Being stubborn today. Here we go. It's out. Sad thing is that every time you do this, you rub off a little bit of the, or at least I haven't figured out a way to do this non-destructively, but it kind of rubs off some of the red sort of protective coating that's on there, and I think that coating is on there to prevent arcing. So you don't want to remove all of that. So yeah, anyways, we're probably good when it comes to high voltage. Next step, we want to put the computer on its face. Let's take off the extension cord here. Come back, Brenda. So we've discharged the CRT. I'm gonna swap back the original analog board. So I mentioned earlier this is the analog board and the neck board. I don't know if you heard this, but they're not original. So I'm gonna swap in the original parts. So yes, a couple of steps to do this. For one, you wanna unscrew the torque screw that holds on the ground lead for the neck board, like so. I'm not sure how you collect screws in under the compartment there. So let's unplug the neck board, like so. And let's bring out a screwdriver. So what we want to do is, so the SE and SE30 are a little bit cumbersome to work on with the analog boards because they have, well, the analog board and then a chunky power supply here, whereas all the other compact Macs, the black and white compact Macs, have just all the components on the analog board. So what I usually do is I start out by, well, there's a little ground lead that goes from the PSU to the chassis over here, so you want to get rid of that. Then you have two screws that's holding on a little metal clip here. So you remove those. And then you have two screws down here on the side, or the bottom right now. And those last four are what's holding the analog board itself on. Like so. So next you want to tackle the four screws that's holding the power supply in place. So this is where they all gets a bit wobbly and unstable here. Everything is held in place relatively well, but you want to be careful so that the power supply doesn't tilt over and bumps into the neck of the CRT or something like that, causes damage. And then the last screw. Like so. So now everything is precariously just floating there. The next tricky part is to unplug all the connectors back here. So you want to well, we can leave the neck board plugged in. We don't need to bring that with us, but we need to unplug the CRT itself. It sits over here. It's always very precarious. And we want to unplug the power supply, which sits in an even more inconvenient spot. So at this point, you may want to just lift out the analog board a little bit and stick your hand down here. Now wiggle it up. So that should do it. And then you lift the whole thing out like so. Analog board out. And yes, so the power supply is kind of floating around here. I think I'm going to put it up onto the side for a moment. So let's set this rat's nest aside a little bit. And bring over the original parts. Neck board here. And lug board here. So yeah, as I mentioned, these were the ones that were installed in this machine in the first place. So I want to put those back in, see if we get the same screen collapsing issue, and see if we can fix that. One thing you always want to do, or two things you want to do when you have an analog board out like this, they are you want to clean the contrast or brightness potentiometer that sits right here, because that gets gummed up very easily and kind of scratchy and gross. You may want to service or lubricate the fan as well. I like to do that. So let's do some cleaning of the brightness potentiometer. Oh, I should have showed that. So what you want to do is just lift the plastic knob right out, like so. That exposes the potentiometer. So I have, what I like to do with these potentiometers, I use deoxide fader lube, or fader F5 even. which is a special. It's a even more lubricating version of the oxide that you want to use on things that move a lot, especially potentiometers. So since this potentiometer is something you're gonna probably go and fiddle with every now and then, it's good to use fader F5 on that. So let's get some of that in here. So you want to do is kind of spraying around the seams with the potentiometer there, and then you work it in, kind of spin it back and forth a couple of times, like so. So that should do it. Now we have probably a less scratchy brightness control. So let's wipe some of the excess contact cleaner here off the assembly. So number two, I like to lubricate my fans. I know some people like to replace these with less noisy modern versions, and I do that sometimes. Potentiometer is the same as a variable resistor. Basically, yeah, I think there are also capacitance potentiometers. They adjust capacitance in some circuits, but it's most common to have, yeah, resistive. I don't know what the correct term is. Yeah, potentiometers that adjust resistance. There also you also have a potentiometer sitting right here. This is the, I'm pretty sure that's the voltage rail adjustments. But yeah, you can test that. Do you want to test that? So let's see here. So we can see the in and out, input and output of this thing. So just for fun, let's try that theory. So if we bring out the, where's my, there it is. My multimeter is hanging out down here. So if we set it to measure resistance, see if, is there any way I can get this to show up? Maybe. So let's see if, I suppose these two are the inputs and outputs. Yeah, so right now it's 0.48 mega ohms. So as we adjust this, now it's 0.65. Let's see, other direction. 0.55. So it's kind of hard to get. Actually, I can do it up here maybe. Point 0.4. No, it's 378 kilo ohms. 300. So it goes down to 350 kilo ohms and up to 0.7 mega ohms. Yeah, so that confirms that this this is a resistive potentiometer. Basically, you control how much electricity voltage should go into CRT. So let's see here. So this may be, some people may be unhappy with this, but what I like to do is I like to peel off the label on these fans. So this will, of course, kind of ruin the original look. I know some people care a lot about the backside of their computers looking authentic. So if you, maybe there's a way to adhese this back, but I usually just put something else on there. So what I usually do is just peel at the edge of this label. This is being stubborn. Very stubborn label. peeling away with my fingernails. Maybe it's possible to drop some Goo Gone or alcohol or something to kind of loosen up the adhesive, but I don't want to get too much non-lubricant chemicals inside of this. This label is basically protecting the bearings in this fan, right? And it's slightly easier to do this, of course, if you remove this fan from its housing here. But to do that, you have to unscrew this whole assembly that's attached here and here. Those screws are really stubborn because they put this like adhesive material on here to keep them firmly in place. Okay, it's coming off, and there we go. There we have it. We have exposed the bearings of this fan. Let me see. Inspect. Let's see if I can find my loop. I put my loop somewhere, can't find it. Anyways, I think I don't really see anything bad in there. Sometimes you can see like specks of dust and grime that are made into the bearings, but this one looks particularly clean. Just using the edge of a cut off Q-tip just to make sure there's a little bit of black stuff coming off, but it's not too bad. So then you want to put some kind of lubricant in there, not too thick, not too thin. What I'm presently using is this, let's see here, it's called Zoom Spout Oiler, the original, and it says the contains the highest quality turbine oil, and I think this is ever so slightly too thin. I wouldn't necessarily recommend this. It works okay, but I'm sure people maybe have better suggestions, so let me know. So let's get some air out of there, like so. I'm just preparing. So you want to get about 1 drop, I'd say, maybe 2 drops of this lubricant. Let's do 2 drops. 1, 2. That's about right. And then you want to spin the bearings, spin the fan with your finger to get it in there. So I think it spins a little bit more freely now. And after that, so you of course you want to protect this bearing again. So and this is, I don't know, people may have better options, but I'm using these color coding labels that I picked up at a drugstore. They may not be the best adhesive, so maybe I should find something better, but they've been doing okay so far. So what color should I choose? Blue, yellow, or red? Let's do yellow. Then put it right on top, like so. Here we go. Should hold for a bit at least. And you know, in the worst case, if I ruin this fan, I'll just get a Noctua replacement, whatever. These fans are easily replaceable. So, one task done. So before I go any further, I need to let's see, there's a neck board. So the running theory is that there is some oxidation inside of here, as well as potentially on the fingers of the neck there. So I'm gonna start out probably by rubbing them with a little bit of alcohol. So I'm gonna rub the neck board, the neck pins a little bit. I'll put some alcohol on my paper towel here, and I'm gonna just rub these pins a little bit. Oh yeah, that's pretty dirty. Pretty dirty. Okay. There we go. And then maybe I'll try some fader loop. And let's not use fader loop for this, because this is a contact that's static. It's not going to be moving around. So let's just use the good old handy CRC QD electronics cleaner. Let's put some of this inside of this contact here. And then let's tilt this up so that the contact cleaner doesn't run down the side of the tube. Let's put this on here. Then let's plug and unplug it a couple of times. Let's put some more in there. Let's plug it. Like so. I think that should be enough for now. So hopefully that will give us a little bit better contact there. The other failure point, of course, is this header and the analog board itself. But we'll clean them out. Actually, let's do that now as well. So let's get some. You really want to do that on all of these headers probably, because they're probably oxidized. Let's put some in the neck board header. Oh, that's the CRT. No, that's the CRT header. Sorry. Let's work it in. Like so. Neck board itself sits over here. So let's get some contact cleaner in there. So that we can be sure that there's no oxidation left. All right, so I think we are ready to assemble this again. So this again is the tricky part, getting all this back together. We want to put the computer down on its face, and you want to put the power supply in. Like so. And then it's always a bit tricky because you have to get the brightness knob in underneath the power supply. and then slide the analog board in, like so. That should do it. And at this point, it's a good idea to connect the CRT and the power supply onto the analog board. There we go. Go. Right. So it's also a good idea to connect the neck board at this point. Actually, you wanna let's see if we can. You want to hook up the logic board connector as well, so it gets pretty tight underneath here. Actually, the logic board connector is probably something you want to put some contact cleaner in as well. Like so. And then the neck board. Like so. So at this point, time to screw it back together. So I like to start out with screwing the power supply onto the analog board. Like so. Oops, sorry. So the screws that goes into the power supply are different from the ones that goes into the chassis. They are the finely threaded machine screws. So you don't want to try and force one of the chassis screws into the power supply. That's not going to go well. And vice versa. Yep, this is a tricky part. You need to find the holes there. Shift the power supply around a bit, like so. It's not taking, come on. There we go. All right, it's in there. Unfortunately, at least I haven't figured out a way to do this, but I don't think you can screw in the power supply first, and then, you know, when these are outside of the computer, because unless oh yeah, you can probably do that. If you take out the CRT tube, the tube itself, you can probably assemble these two on the side and then put them in, and then put the CRT in. Right, that's probably how to do it on the assembly line. But if I don't really want to take the tube out because you have to mess with the torque screws that's in the bezel, and I don't want to make it harder for the plastic. The plastic is brittle enough as it is. But yeah, so if you're doing it like this, you have to fiddle around with it. You have to find the fit for the logic board. The holes. Okay. There are the holes. Okay. Oh crap! Sorry. I need to have this little grounding clip on here as well, just for safety, because you want to ground the analog board firmly into the chassis. I'm not tightening these screws quite yet. We'll do that in a moment. Alright, and all the screws are in place. Actually, so we don't forget, we also have to attach this ground lead, the power supply ground lead, into the chassis as well. For good security. There we go. Okay, let's tighten all the screws. Tighten the screws. Tighten, tighten. And of course, we need to attach the neck board ground lead firmly into the bezel. So it's this ground lead coming off the neck board. It's super important that it's grounded against the chassis, and there's a specific spot for that in this corner of the CRT. So with these plastic screws, I make sure to first screw counterclockwise until you hear a little tick, when the little bump when the screw fall into the existing thread. You don't want to create new threads in the plastic all the time, because that's gonna ruin the plastic pretty quickly. Let's put the neck board. Neck board just goes on like so, and also of course the anode cap needs to be clipped back on. Just put one. Oh crap! I keep making dents into the coating there. Actually, I should probably wipe this off a little bit. There we go. Putting the clip back in. The clip in. It's in place. Alright, I think this computer is ready to test again to see how well this is gonna work. I expect, unless I plugged something back in the wrong way, I expect it to at least boot up. But if the collapsing problem remains, we'll see that after a couple of minutes of running the computer typically. Anyways, so Yeah, so let's pop the logic board back into the computer. It's over here. Actually, to do that, we need to put it face down again, obviously. So the way you insert logic board into these later compact Macs is, first of all, you attach the speaker lead into its little header. It's over here. Speaker lead goes in here, like so. And then you put the left side of the board into the rails on the left. And then you have little openings that are lined with some tabs on the side of the PCB on the other side, and then you kind of clip it in, and push down, and it's in place. And of course you have to attach the analog board connection. That's this thick lead here. You probably want to do some contact cleaner in that one too, just for good measure. Like so. All right. Let's oops. So when you don't have the back housing on, there's a little bit extra pressure on the logic board on the back here, so you need to be a little bit gentle with the computer. And of course, word of warning, these high voltage labels are there for a reason, and so it's generally not advisable to connect this up without the back case on. But you gotta do what you gotta do. So turning on the computer. There you go. So we got a picture, which is helpful. Let's wait for the question mark. There it is. So it's alive for at least a couple of seconds so far. Now let's boot into macOS 7.5 just to show off that that actually works again. So let's you want to look carefully before you touch the back side here. There you go. It's off. Just to get a full setup here, let's put the RF shield back on as well. Slide it on like so. Back of the computer. Like so. So it's a bit tricky when the RF shield is there. It's in the way. More or less back in one place. So, okay, so it's getting caught up on something there. Not sure what. Let me double check. This RF shield is really obnoxious. But this the 6830 bus is pretty noisy, I think. So it's pretty strong signals. So it's not a bad idea to shield that. Super obnoxious shield. Okay, I think it's on there a little bit better now. So last time it was when the computer was put back together like this, when the screen collapsing happened the most, and I think that was because you know, everything was compressed together, not compressed, but there must have been some pressure on some of the leads inside, like the interconnection leads inside, that caused some lack of connection or some short or something. So this is going to be the real test. So let's also hook up ADB. So we have keyboard and mouse over here. I can show up. Let's see here. There's a keyboard and mouse that's over here, like so. And also have SCSI. I'll hook up this external SCSI because we don't have internal drives right now. And right over here I have a PySCSI sitting around. This is on a 0 RPi0 W2 or 2W. We're running the latest PySCSI software. And let me show off. Let's see here. So I have the PySCSI control page sitting right here. We have a boot disk. We have an Ethernet adapter, and we have a CD-ROM drive without anything attached. So all of these devices should be exposed to the computer. So let's see what happens when we turn her on. Yeah, I was lucky to acquire a bunch of Pis before they became impossible to get. So let's see what happens when we turn on the computer. Still chiming. Happy Mac. All right. Okay, it's kind of hard to see. Let's turn on brightness. There we go. So yeah, it's the familiar System 7.5 Splash. In black and white. It takes a good long while to boot, but it will boot. Sometimes I get paranoid and start moving the mouse cursor just to make sure it hasn't hung. But yeah, it's dutifully booting up. Like so. So yeah, here we are. It's booted into System 7.5.3. Now I don't have anything. This is just a PySCSI bootstrap system image. It's a tiny image. There's nothing on it. Let's see. Anyway, this brightness control knob is really stiff though. I think it's held on by something because it was very nice and smooth when the analog board wasn't installed, but I think it's stuck on something. So maybe I have to kind of wiggle with the case. Maybe it needs to be pushed together a little bit. But then let's slap it around a little bit here, see if we can get it to get messed up. Oh yeah, that's great, Brandon. Yeah, we're great minds think alike, huh? Those classic Mac OS is prone to just freeze up on you at the most inopportune moment. So it's good to be paranoid about that and make sure that the code is still running. So yeah, so far so good. It's not dying on us. So let's shut it down for a bit. And we're gonna do another fun thing. So if you remember from the first time we looked at this computer, it actually came with something fairly rare, something fairly desirable, as I understood. Jeez, this is... There we go. Namely, and so it didn't collapse because we worked hard on cleaning all the connectors, and so the running theory is that there was some pretty bad oxidation on the neck board, the connectors on the neck there. So I spent some time kind of polishing those pins just earlier. And yeah, maybe I should have demonstrated. I have a picture of the collapse I can show you. I don't, I didn't really want to simulate it because whenever, a signal collapses on a CRT, especially black and white CRT like this, when you get very extremely high brightness on a small spot, you risk burning creating burn-in, right? Burning out the phosphor. Anyhow, so this computer came with one of these Micron video boards. This is a PDS 030 card, and you can drive an external VGA display, and also you can, with the special header, you can actually drive the internal CRT, I've learned, and you can get a grayscale image on the internal CRT. So that would be a cool mod to do if I can figure out how to do it. So let's pop this bad boy in here. It slides in. Bit fiddly because it has to go through a little opening here onto the logic board, and then this little header cable plugs into one of the headers, like so. And that goes into the DB15 port that's on the back. It's the back plane here. And I have the adapter sitting over here. This is the DB15 adapter. So this goes from DB15 to compact D-sub, whatever it's called, what we like to call VGA. So anyway, the board is on there. It can be screwed in. I have the screws over here, but I'm not going to do that right now, just in case I need to take out the logic board and mess around with it. Back on. Like so. And then we plug in the adapter like so. And then I have a VGA cable sitting around here. I'll show where it goes in a moment. I'm gonna hook up SCSI. Gonna hook up ADB power. Slide her over here. Oh, and before I forget, I should definitely briefly show what I was talking about. I'm gonna bring up the photo I took. Yeah, so this is one of the photos I took. So basically, what you saw was that at first the screen started to flicker a little bit, and then the screen kind of collapsed into one of the, sometimes it was a bit further down. Oftentimes the logic board would continue to run, right? So you could actually see the cursor move around, but this was the image was duplicated here in these two little spaces. And yeah, this happened pretty frequently during operation. So who knows? Maybe you'll get to see it in a moment. Hopefully not. But so I'm gonna just head back to BlueSCSI, and I'm gonna just insert a different image. So this is the full system 7.1.1 installation that I did, like so. Now it's gonna be booting into 7.1.1, hopefully. Oh, oops, sorry. Before I do that, I need to show you the VGA cable. It's a bit of a mess here on my workbench. Goes into this open source scan converter. So it's hooked up here, and the scan converter is on. I'm gonna turn on this monitor, this TV. So the scan converter is hooked up to the TV here. You can see the pattern of the scan converter. I'm gonna turn on the computer again. Gonna press the scan button, like so. Come on, let's see if we can find the signal. There you have it. That's a Mac screen on the big screen. It's horribly noisy. You may be able to see the horrible jail bars here, and there's a lot of noise in the scan lines. So either the shielding, well, the video card sits right next to the CRT, so it probably gets interference from the CRT. And it's unshielded. Maybe if I can build like a shield for it or something, it would be a little bit better. But it's pretty neat to have a 640 by 480 basically VGA compatible signal that you can do whatever you want with. Would be cool to do the internal grayscale mod as well, maybe for another day. So what we can do here, just to demonstrate that everything is a-okay, I'm gonna run Mac Test Pro, which Brandon recommended. Thanks, Brandon. So I'm gonna run the. So of course it's not super thorough because we're not booting from a rescue disk, but we are inside the OS. So let's run the the classics tests. Oh, and you know what's cool as well? It's dual screen right now. So actually there's a frame buffer on both of these, and macOS knows of both. So you can move stuff onto the other screen. At least my cursor can go over here. It's hard to see in the camera there. But in a moment I can move a window over just to show. So for instance, let's move this over to the screen here, like so. There you go. So you can be productive. You can have Photoshop and Word up at the same time and do all sorts of shenanigans with your Mac. Yeah, it's a pretty good upgrade, you know. If you have a compact Mac, if you had it at the time, I mean, you could make your SC30 a lot more capable as a desktop computer. Once of course, you can, you got a cheap off-the-shelf PCVGA monitor, and you had a ton of functionality right there. Anyway, so let's run the logic board tests. So let's start with the non-destructive ones, the ROM and the FPU and the SCSI tests, just to demonstrate that it works. Yep, so all of those tests passed, it says. Next, let's run the VIA test and SCC tests. So these require a reboot. They're probably destructive in some way, messes with the memory or the state of the chips or something. VIA test is running. SCC test is running. And they passed. Happy, happy. We can run, let's see if I check that. We can run the VRAM tests, VRAM, see what happens. Well, now we have an expansion board. Maybe something will be messed up when we run the VRAM tests. Oh yeah, it does not know what's going on with the frame buffer here. It's just doing a section of the VRAM. It's interesting. So it's actually using, I guess, the onboard VRAM for set part of the 8-bit frame buffer here, and then the 1-bit frame buffer on the internal monitor is running off the memory on the graphics board. That's pretty cool. Let's see if it's able to recover from this and not crash. Pretty thorough VRAM tests. Yes, you can rewire the built-in CRT and get 8-bit grayscales. I believe. At least some grade. I don't know if. Yeah, I assume so. I mean, I assume the monitor is capable of that. Yeah, so while that's running, the one piece of maintenance that needs to be done on this computer is the drives. So here's the drive bay. You have the floppy drive here. No, the hard drive is not installed right now because it's big and chunky and noisy. So I want to get a BlueSCSI installed. The external do cutscenes in color. Well, you can do 256 color. So this is 8-bit, 256 color on the Samsung here. Oh, by the way, funny coincidence is that the the CRT, the tube inside of this Macintosh is also a Samsung display. So yeah, and this is an old Samsung LCD that I found for free in my building. So anyways, while it's running its tests, I'm gonna start taking the floppy drive out, because these floppy drives you want to clean and lubricate them. Of course, in this day and age, floppy drives are only marginally useful because you have. Oh my gosh! I'm gonna try another screwdriver. There we go. Need to get more torque to get these screws out. So yeah, it's a bummer that there's so much noise in this video signal. Maybe I can build my own shield around the card and see if that makes a difference. But perhaps if you hook it up to an actual CRT monitor, it's more bearable because the CRT will cover it up. Okay, screws are out, so let's actually I should remove the ribbon cable. So these all these are the internal floppy drives for Sony made. There's this long story about how the partnership between Sony and Apple sort of came along. Yeah, I can try CRT. I have a PC CRT sitting down there. Anyway, so all these early Sonys are really well made, sturdy, very straightforward to disassemble and clean and lubricate. And to be frank, this is a really clean drive. There is really not much dust in there. Sometimes these are absolutely filled with grime. This one looks pretty good. So I may I may not even bother lubricating. Oh, sorry, to do deep cleaning of this one. Let's put a floppy disk in and see what happens. Let's do this. Insert this way. Like so. Oh yeah. Oh, okay, now it's testing a different section of the VRAM range there. Yeah, even the auto insert is super smooth. So maybe I'll just lift some dust bunnies out of this. See if I can get my tweezers. I need a better tool storage. So I just want to lift out some dust bunnies, all these dust bunnies that sit in there. Here. Back there. Let's turn on the light a little bit. Of course, the one thing to be mindful of is, it's well known at this point, but one of the smallest gear in the eject motor, the one that sits right on top of the motor itself, is made of a flame retardant material, or it has some kind of chemical structure to it that makes it prone to get brittle, to yellow and get brittle, and that is practically guaranteed. So it will break sooner or later. I think I probably have. You have spares, yeah. I think got them from you, Brandon. Spindle motors seems to spin pretty freely. Some more dust bunnies. Let's remove them. Of course, the one thing you want to do is to clean the reed head, magnetic reed head. So take some alcohol. Yeah. Well, I'm not sure if the eject motor gear is necessarily made of cheese. I think it's more of like digestive biscuits, you know, shortcake. Oh, sorry. So just show off here. I'm just wiping the bottom reed head, top reed head. But let's try this, let's test it. Let's test this floppy drive and see how well it works before we do anything further. And I'm gonna stop this test because it's obnoxious. Can we stop it? Probably just gonna hit the power button. It's annoying. Okay, let's disconnect everything. So of course, testing the floppy drive without screwing it back all back together. Actually, I'm just gonna loosely put it back into this this drive bay. There are tricks you can do to kind of sort of test it outside of the machine, but I'll set that up if I need that now. Alright, let's pop this floppy disk assembly, floppy drive assembly back in here. And of course, that's kind of obnoxious with this whole video card thing going on here. I'm just gonna pop the video card out actually. So, slide this thing in. Always fiddly to plug the floppy ribbon cable into the logic board. Come on. There we go. It's inserted. Like so. I think we have access. Yes, I think we have access to the floppy drive fairly neatly now. So let's just go for broke and see if we can boot off floppy disk. And in fact, this computer came with a bunch of floppy disks, so I haven't tested them in other computers, so I don't know if they actually work, but let's go for broke and see if everything just works. Let's boot off System Tools. See if it goes in there. Seems good. Let's turn on the computer. Oh no, for earlier I was using a floppy emu. Okay, it's booting. It's the first time I try to use this floppy drive. Sorry, please started loading the OS. Oh, okay. It's always disconcerting when it stops reading from the drive for a couple of seconds. There we go. So we know that it can boot. We should probably let's see, there are system tools. This is a version 6.0.3. Let's see if when we shut it down, we're gonna hear the eject mechanism kick into gear, literally. See if it works, or if we're gonna get crunchy noises. Works for now. So that's a working floppy drive until it gets gear destruction internally. But I think refurbishing that floppy drive is probably for another video. Sorry if I gave the wrong expectations. So I think the last thing I want to do is just to build a BlueSCSI V2 and pop it in here to have an internal drive to work from. I think that would be neat to have. So let's unplug this computer for a little bit. So a BlueSCSI V2 is very much overkill for an SE30. Just not, but I thought it would be kind of a fun thing to do. Let's put the ADB accessories aside a bit. Let's bring out some soldering gear. Like so. Put some moisture on the little pad. This is just distilled water. Maybe that other mic. Yeah, let's try. Testing. Let's. I'm gonna turn the webcam down to minimum. Can you still hear me? Testing. Yeah, so I don't video capture device. Okay. Yeah, let's see how it goes with the fume extractor. So anyways, I have a BlueSCSI V2 kit right here. This is the kit itself. Just it's actually easy, in a sense. It's easier to assemble than BlueSCSI V1 because it's mostly SMD components that can be assembled in the factory. And the only thing you need to do is basically solder on the microcontroller and solder on the various headers, and you should be golden. So this is fairly easy. process. So the kit came with a nice letter from Mr. Eric Helgeson, printed on an image writer too. Always nice to see classic bitmap fonts. I have this is a mounting bracket for BlueSCSI V1, but the mounting holes line up with the V2 as well. It's just that it will be kind of a little bit awkwardly lined up inside the computer, but I think it will be okay. And then I also have a SD card prepared right there. So yeah, let's try to assemble this thing. So we have an angled 50-pin ribbon cable header. See if we can get a slightly better angle. You have the various, oopsie, various headers and jumpers. You have the Raspberry Pi Pico microcontroller. It's hard to get it to focus on that one. If you move the narrow camera point at you to the right, it would be almost like one big picture. The horizontal hold is off. And move the narrow camera point to the right, like so. Now it's farther to the right. I don't know if that's what you meant. Okay, here's the Pico. And also the bird connector sits right here for, needs to be soldered of course, for extra power supply. And that's basically it. It's really, really simple. So we want to solder the headers for the the Raspberry Pi, not the Raspberry Pi Pico, the angled 50-pin ribbon cable connector. We should probably bring up instructions. Just need to the screen layout. Ah, okay, I see what you're saying. So if you move myself over here, clever. Like so. Yeah, I see what you're saying now. It's logically more coherent. Of course, let's see if I can find it. I'd like to there we go. I like to use a bit of blue tack to assist with soldering. So the completed build should look... actually, that's not a good picture. So the instructions basically says assembly, flash the Pico, okay, solder the 50-pin connector and 4-pin Berg, solder the headers to the Pico. Optional, solder sockets to the BlueSCSI board. Probably, I think I'm pretty confident with the quality of the Pico. For the V1 BlueSCSI, it's good to mount BlueSCSI, blue pill in a socket, because blue pills are notoriously, well, because basically you get clones, right, and they're dubious quality. Solder the Pico or socket to the board. Pico's USB port should be facing towards the BlueSCSI logo. Blah blah blah. Install pins for jumpers. At least install power on, term on, and S1, S2. I also want to install LED, I think. So yeah, let's start by flashing the Pico. This is where I should have looked up how to flash the Pico. Let's look at the code. So it has one release, two releases. This is a nightly. Okay, so one stable release. I assume you want the bin file. Yes, it says it placed the bin file in the root of the SD card. Next power up, it will flash the firmware. Okay. So we have the SD card method, and we have, actually, I'm gonna reuse the built-in. Let's see where did I put the let's see here. Drive bay. Losing focus. I don't know where I put the drive bay. Oh yeah, of course it's inside the computer. Oh my gosh. Yeah, so it has an orange LED out of the factory that I can reuse. Anyways, USB method. Download the latest UF2. Hold down the button on the Pico module while connecting the USB cable. The Pico will appear as a USB drive labeled RP2. You can release the button. Copy the UF2 file to Pico's mounted USB drive. After the file has been copied, the Pico will automatically eject and restart. You can verify a new version by looking at the log text file on the SD card. That is very cool. Okay. So I assume this doesn't require any kind of other prep work. So it says starts with flash to Pico. So let's try it. Let's do the UFT. Let's get the UF2 file. We can disconnect the. Let's shut down the programmer for a bit. So we have the Pico. Yeah, has a micro USB port right here. So I should grab a micro USB cable. I'll just grab it from my drawer over here. Like so. Let's hook it up to the computer, see what happens. so here pops the our Pi RP2 device. Let's grab the UF2. Pop it in there. Oh, it unmounted itself. And it stopped flashing. Oh, okay, so now it's flashing 3 times. Yeah, let me show you. There you go. So it's flashing 3 times and then stopping, which 5 times. So I assume that's the that's kind of the error code for no SD card detected. So let's power this down and solder this thing. Turn on the power. Let it heat up. I'm gonna grab some my blue tack to help me manage. Just grab a strip, some blue tack, just to hold components in place. Actually, I need half of that, I think. So we can start with the bird connector. That's easy enough. I don't think I even need blue tack for that. It sits there pretty well. So I'm gonna use some flux. Some flux on there. Grab my soldering wire. Oh, and I'm gonna turn on the fume extractor. Okay, bird connectors connected. Next, let's do the angled 50 pin header. Let's use the blue tack to hold it on. Some flux on there. Start out by soldering one pin, and then we make sure that, there we go, the angle of the header is good. Solder another few pins. Let's remove the blue tack. Do the other side. Put it on. Seems good. Let's put some more flux on here. Drag solder. Like so. Some more flux. go. Let's go over the solder joints a little bit. All right. So the 50-pin connector is on. Looking good. Now the tricky part is to get the headers and the Pico aligned well. So the USB port should be facing the BlueSCSI logo. So the end result should be something like so. Probably better to do it the other way around. So what we probably want to do is I'm gonna solder one pin each again on each side of the Pico headers. So oops, it didn't work. Fell out. Sorry. So it's not sticking. Nope, that's so weird. The solder is not sticking to the pin. Probably need more flux. There we go. So now 2 pins are soldered on each side, on the same side actually. So I'm gonna pop this into its spot on the board here. I think this header is kind of bad quality. It's behaving so weirdly. Oops. Anyway, so it's firmly in place there. I'm gonna solder the rest of the pins on the Pico. we go. Now we want to solder into the board itself. Seems okay. I've just anchored 2 pins. I'm gonna solder the rest. Alright, so we have a Raspberry Pi Pico installed on this board. Now, the final stretch is just getting the little headers on here. So I want the S1, S2 LED power on. I think I have already prepared 2 pin headers. Let's do the LED. This is where it's good to have a little blue tack to hold this in place, like so. Power on. What was the other one we wanted? It said TRM on S1, S2. TRM1. TRM on. Oh, it's right over there. Okay. Like so. S1 and S2. So I'm out of 2 pin headers. I'm gonna just cut this down to size. So, oops, a bit too much plastic there. Put blue tack on. All right, and I think it's done. Although, yeah, these sometimes you need to go in and adjust the orientation of these pin headers. You have to be careful not to press too hard on the pin edges while you solder them, because it's easy to push them through. This is a little bit of a disaster. Look what I did to. Okay. Look what I did to that pin header there. That's not happy. I think that's acceptable. All right, let's just clean this up a little bit. Sprinkle some alcohol. See if I can find toothbrushes. Like so. And still haven't found my loop. So let's inspect the work under the. Oh, actually, the loop is right over here. Okay. Probably get some alcohol on top of the Pico as well. Like so. And I think the joints look all right. All right. So let's just see if this thing works out of the box. I may not have time to really assemble and like put everything inside today, but let's see if we can get something going with the SIM card. So I'm gonna format the SIM card. Let's see if there are any instructions how to prepare the SIM card. Tests. Powered via USB with no SD card. The power LED should be lit and the Pico's LED should be flashing 5 times. It was flashing 5 times for sure. Yeah, let's see. Insert an SD card. If the flashing lights change to 3, you have no images on the card, but he was able to read it. Okay. Try booting in the vintage computer. All right. So let's format the card with FAT32. I think is the going standard. Format complete. So at first let's try to power it without or with the SD card or without the SD card first. So let's see what happens. Okay, so the power LED starts. That's a good sign, and the flashing happens 5 times. Now let's a FAT32. Okay, maybe I should redo it in exFAT. Let's see if we get 3 flashes instead now. Still 5 flashes, right? 3, 4, 5. That's weird. So it doesn't like... Let's see what happens if we put an image on there. Alright, fine, I'll format it with exFAT. Done. And I'll put something on it. Let's see. Let's put a PySCSI boot disk on it. Let's try 701. So that's what I have right here. So I think we have to name it in a specific way. This sheet says naming convention is HD XY, where X is the SCSI ID, let's say 6. Y is the LUN, let's say 0. Underscore, oops, I have set a Japanese input. Underscore 512 for the sector size, and then just 701 as the just a random label, just system 701. And so Hook it up again. Connect it like so. See what it says. Okay, so it's not seeing the SD card, it seems. So sorry for the anticlimax. I think I have to wrap it here. It's time to have dinner, take care of the dog and the wife. So we have a assembled but not quite functioning BlueSCSI. So we'll pick this up next time and see if we can get it to work. So thanks again for watching the New Old Computer Show, and see you all next time. Bye.